Hello and welcome. We are Group 6. Today I'm here with Ro, Fatima, and June, and my name is Maria. And we are pleased to be a part of the ASEC case competition today. Yeah. And so we were tasked, during this competition, we were tasked to develop a perspective on how weather patterns, locations affect electrical demand, price, and load at the Spanish Annual Energy Conference. And so this is our introductory dashboard. It is a navigation system to our 4 different tabs. One of them has 2 different graphs, or 2 of them have, and it is just a form of organizing our data and having a visual representation, or a way of organizing our visual representations. And so on the first square, we see a comparison of the total actual load and the total load forecast. And the second box on the right-hand side, we see a comparison of a price actual and price ahead on a monthly basis. And then for the bottom 5 squares, we see a comparison of wind speed per city, because we found that wind speed was a top contributor of energy generation within this project. And then within this pie chart, we are able to see the average amount of energy that is produced in all cities, categorized by the type of energy produced. So we have the nuclear, fossil gas, wind, coal, and reservoir. And then we have a lot of different little ones, but they just do not make up the majority.
So now we get into our 2 demand versus load graphs. So as you can see on the bottom, the x-axis is split up by month, quarter, and then year. And so for this graph, we are comparing the total load and the total load forecast. And as you can see, they match quite closely. Next, we get into the comparison of total price and the price forecast as well. And as you can see, they do follow along the same kind of pattern too.
Next, we have the energy generation bar chart. As you can see, it is broken down by the different quarters of the year. And so the total bars make up the total actual load of energy, and each of the colors represent the different generation factors such as wind, fossil, nuclear, hydro, and solar. And next, we have the average energy generation versus the average wind speed per city. So the bars in the back represent the total generation of wind energy, and the different line charts represent the different wind speeds in the different cities. And as you can see, the trend of the graph follows with peaks representing the highs of the generation wind when there is the most speed. And next, we'll see a demo of our data visualization report.
So as you can see, this is our demo. We have the title, and then we have our navigation buttons here. You click a button, you go into the chart that it has. So when you click that, you can see exactly the ratio for each, and you can also filter here. So we have our 2 graphs here, then the total energy generation and the KPI chart. And then we have our demand versus load. And then we have our energy generation bar chart and our energy generation versus average wind per city. So the way that we aggregated all our data together, as you can see here, is that we split up the weather data into the corresponding cities that it's from. And then we added them all in as separate columns within the energy data set, so we can match the time of the energy data with the time stamps within each separate city as well. And that's kind of how we got our main data set that we use for visualization. So then thank you guys so much for the opportunity. And yeah,